Hello and welcome to Calculus 2. The first lecture is on 6.2, area between two curves. So let's start with a little refresher from Calculus 1 on how we calculate areas in general, and then upgrade. So some of the stuff we do in this class will be straight upgrade from what we learned in Calc 1. So say that you have a linear line, horizontal line y equals 3, and you would like to know what is the area under the curve between 2 and whatever this number is, 7. The way you set up the integral is you say area will be the definite integral of from a to b of function f of x dx. What you learned is that dx is the same as that delta x, which used to be b minus a over n. So what you know is that these limits a and b along with dx are providing the width, and the function, which is y equals f of x, is providing the height. Width times the height is area of the rectangle. So what we are going to do here is we are going to understand that there are two independent dimensions which are multiplied, and we are getting a two-dimensional concept called the area. So these two together are width, and that width is multiplied with the height. Height times width is area. When we are setting this up, and it wasn't a big deal in Calc 1, but it's going to be a huge deal in Calc 2, and even bigger in Calc 3, is representative rectangle. Representative rectangle is any of those slim delta x width rectangles, which is a representative rectangle for the entire area. This space, the shape we have, in this case rectangle, is filled with infinitely many of these infinitely thin rectangles. And when you add all of them, you get the overall area. This integral symbol is stretched S, which stands for sum. You are adding infinitely many rectangles together. These rectangles are infinitely thin to capture the curvature on top, and in our case today, bottom, right? And all of these rectangles, we just need one, because we can actually think the entire situation, we can reason with one rectangle. Because I will set this up by saying this representative rectangle swipes the entire area. It starts right here and goes across, going through every single position between 2 and 7. So I will say that representative rectangle dx slides from 2 to 7, and there is your width. It's left to right, so 2 to 7 dx. And if you take a look at the height of the rectangle is hitting the function on top, and the bottom rides on 0. So you technically have 3 minus 0, but it's just 3. Because that's the function. That's f of x. The y equals 3. F of x equals y, right? So now you have this integral. I'm just going to write it 3 dx, which we can integrate to get 3x from 2 to 7, and then compute definite integral. 3 times 7 minus 3 times 2. 3 times 7 is minus 3 times 2, everything equal to? Exactly. Now, you know that you have rectangle, and rectangle is width times the height. Your width is 7 minus 2 is 5, times the 3 is 15. So next time someone asks you, why is the area of the rectangle length times width? Don't forget about representative rectangle. That adds like 15 minutes to the story. Assures you they never ask you again. So this is how we set it up. What is the area for the triangle? Exactly. Half base times the height. What's the cool formula for the area of the triangle? It's a equals integral from a to b f of x dx, like for everything else. When you know this one, you can forget all areas you ever learned, because this covers them all. They all came from there. So here is some triangle over here. Happy that it exists. That's a 6. That's a 4, okay? Good. X and Y. Now, what is the area of this triangle? Wow, that's impressive to do it that fast in terms of figuring out the function, integrating, plugging in limits. But that's okay. All right, so let's figure out, what's the name? I'm sorry. I'm sorry? Evan? All right, let's see what Evan computed in seconds in his head. So first of all, he figured out that the function over here, f of x, is equal to rise over run. It falls on the negative, so it's negative slope. So we have negative 2/3 x plus y-intercept is 4. So he figured out the function. Then he sets up the integral from 0 to 6, because my representative rectangle, dx, is going to start swiping at 0 and go all the way to 6. So limits are 0 to 6, and we are integrating negative 2/3 x plus 4 dx. Don't forget these parentheses, because remember, it's times dx. dx is the width, and the function is the height. So it's height times the width. So you must have those parentheses, because it's not just 4 times dx. It's everything times dx. So now that we have that, we quickly integrate this. So x squared over 2 cancels 2, so negative x squared over 3 plus 4x, computed from 0 to 6. Plug in 6, plug in 0, that's just going to kill everything. So we have negative 36 over 3 plus 4 times 6 is negative 12 plus 24 equals to 12. Very good with this stuff, man. Nice. Or you cheated. I use the lane formula. So next time someone is trying to quickly recall the formula for area of the triangle, you have a 5-minute calculation instead. That's why we paid $3. Math. 6 of us know it. The rest? Did I welcome you already to 1%? No? Welcome to the 1%. How does it feel? 1% of students at RUCC take Calc 2. Do you feel any special?
You should.
How many pairs?
I'm sorry? Well, there are multiple sections. So in some sections more than others.
What percentage of overall math majors?
How many of you are math majors? High up, high up. Of course. That's 3. Okay. All right. Guys, this is what you're looking forward to. Math and no hair. You might want to reconsider. The rest of you are fine. But guys, who cares, right? You might want to reconsider now. All right. Career choices?
How much of that actually shows up on the live stream?
All of
Is
it.
it just like 2 minutes of slightly muffled conversation? Like, can you?
I hope it is.
Oh yeah, that's what happens when you watch the stream. There'll just be like 8 minutes of silence.
Yes, that's when you are doing the problem. Yeah, so you can just kind of forward it to when you see some writing come up.
Just imagine like being on the other end, listening to it live, and just 8 minutes silence. Sometimes like 20 minutes.
It tests people. Yeah, that's actually good, because I really don't want people who have short attention span. It's just, this is mathematics. It requires discipline, right? Which is why the class starts at any point. Now that we mastered this, we would also look at other situations that are, in some cases, dangerous in mathematics, and that is when the function dips below x-axis. Does anyone remember what happens in that case? Yes?
You take the 2 areas, one above the x-axis, one below.
Yes. We have to split the integral, and what happens with the area that goes below? Yeah?
You have to take the absolute value.
Yes. You subtract, so minus minus will give you plus, or you do the absolute value and add. Good. My favorite example is area under sine curve from 0 to 2 pi, because we have these two symmetric bumps, 0 to 2 pi, and halfway is pi. And if you just use fundamental theorem of calculus, which is definite integral, and you just go integral sine x dx from 0 to 2 pi, you are going to get 0 as the answer. But you know that that's not the area, because you have eyes and you see that there is something for you to color, right? That's area. So you know that the answer is not 0. But the integral did give you 0. So what you are going to do is you are going to actually split this into 2 integrals, because the integral above x-axis will give you positive area, and the one below will give you negative, and in this case, because they're the same, they actually cancel out. But what you are going to do is you're going to take the integral 0 to pi sine x dx, and you are going to add the absolute value of pi to 2 pi sine x dx. And eventually that will give you 4. So you have to be careful about that. All right, it's time for Calc 2. Area between two curves. Every time we computed the area, we only looked at the curve on top, and then we said the area between x-axis and area between f of x is, and then we computed with the integral. But now we are going to have, let's say, a parabola intersected with a linear line, and we would like to know the area between these two curves. Now, the way this works is, well, somewhere there's going to be an x-axis, and these intersection points, A and B, are going to be the limits for integration. Now I'm going to call the parabola f of x and the linear line g of x. We will see that the one that it's on top is f and the one on the bottom is g. We'll see that later. And now if you think a little bit about this, how would you compute this? Well, you will compute first the integral of f of x dx, which will give you all of this. So it includes the area that you want, the shaded upper region, and it also includes the area below the linear line, which is what you don't want. So that has what we want plus more. Then you want to compute the other integral, which is g of x. Now that part is going to compute this. So I hope that you see that the difference between these two will give you exactly what you need. So all of these limits are from a to b. So the f of x integral computes all the way to x-axis, so it gets you everything. G of x computes only what you don't want. When you subtract the two, you get exactly what you want. Do you require the real example for this? Banana. It has the part that you want and the part that you don't want. When you peel off what you don't want and throw it away, you're left with what you want. Make sense? Or you buy something, right? It comes in wrapped in that protective force field shield that you can't cut with anything, right? And after 30 minutes, you have the thing that was inside. I call those things artifacts because whatever it is, could be figurine or whatever, it's like you can never get it out. Anyone wants to be a packaging engineer? It's a big field. Okay, guys, please fix that. Right? Figure out a material that would keep the artifacts inside, but then you could just reach and get it. It will involve a little bit of quantum physics, but that's okay. That's what we need. So what is the formula for area between two curves? It's going to be FAB of f of x minus g of x in parentheses dx. Top minus bottom. Top function minus bottom function. That's what it is. Now we can also do this sideways. So area could be c to d of f of y minus g of y dy, which is right minus left. Actually, right minus left is not good to say. The better way to say this would be the further away from y-axis minus closer to y-axis, because it could be on the other side as well. Anyway, we should do some examples. And then go to the next lecture. So I will work out two examples. Before I do any of the examples, I would like to point out simple stuff, tricky stuff, and so on. So we're looking at the textbook examples now. This is problem number 5. And you have a linear line, you have parabola. Linear line is on top of the shaded region, so it would be x minus x squared minus 2. And then that minus would change that into plus 2, which is where your grade suffers. And the limits of integration are when you set these two equal to each other and solve that system, because it will give you the points of intersection. Hell breaks loose here, because for the first half, cube is on top, linear on the bottom, and then at 0 they swap. This one is on top, this one is on the bottom. We are saved on this problem here because it's symmetric. Both of these functions are odd, they go to the origin, this is perfectly symmetric, so you can compute one and then just double it. But if this was skewed in any way, tough luck. You have to compute two separate problems. So this is two separate integrals, which just because it's symmetric we can exploit. But most of the time you can't. And it's especially dangerous in calculus, because shape on top could be skewed. And you can't see that very well. But in this case over here, nothing symmetric, but it's only one integral because this is always on top and this is always on the bottom. Now I want to draw something, representative rectangle, and hopefully you guys, you will have to use it whether you like it or not, so just go figure it out. Here's my representative rectangle. When I am setting up the integral, representative rectangle starts here as a point at A. So integral A, and then it becomes bigger and bigger and bigger and bigger, right? And then smaller and smaller and smaller. So swipes all of the values between A and B. And look, the top of representative rectangle is always riding the x function. So that's your f of x. Minus the bottom is always riding on the red function, which is g, which is x squared minus 2. Is insane amount of parentheses, you need them all. So now you fix that and then you can integrate. Representative rectangle here, the top of representative rectangle rides x cubed all the time, and then the top of representative rectangle rides x. You see that? So they swap. F becomes g, g becomes f. That's why you can't do one integral on this problem. Are we all agreeing on that? So make sure that the functions are not flipping on you. Intersect sine and cosine. Look at that beauty, right? Cosine on top, sine on the bottom, then they swap again from 0 to 2 pi. No symmetry. You have to do through 3 integrals, right? That's what you do Sunday morning when you have nothing else to do. More examples. More examples. Over here, we're looking at another example that with my representative rectangle, easy, top always rides the linear line, therefore f of x is whatever the hell that is, 3 minus x. Bottom is always riding 2 to the x, so to set up the integral, 3 minus x minus 2 to the x, and then good luck integrating. Next problem. Two even functions. Awesome. Symmetric interval. Awesome. Kill that. Just do the half of it and double it, right? Exploit symmetry. clearly black line always on top, which is the cosine one, secant one always on the bottom. So subtract them and you're done. Beautiful. Ta-da! If you draw your representative rectangle here, right? What now? Two areas. There is this integral for the black line, and then the integral for the, what the hell is this, red or pink or whatever it is? Out. I've seen 16 colors. I can't even spell that. Just leave it. Pink or red, what do you say? Purple, violet? By executive order, it's red. No discussion. If you don't like it, sign up for someone else's class. I believe there is a 7 a.m. class, guys, that has spots. No, I'm serious. Parking is awesome. You can park anywhere. Like you can park across 3 parking spots like that, and no one will say anything. That's how 7 a.m. and park right there in front. That's yeah. 7 a.m. course is awesome. So you do this one, and then you do that one, and then you add them up. Now look at this. It's called magic. Pull that out of speed. That and a rabbit, same time. So when you look at this, you can find the area between two curves. You say red minus black. But your variable must be y. Now, let me just make an argument of why would you possibly consider something like this. So the first way, I'm asking you to compute integral from whatever this mysterious a point is to 0 of square root of x over 2 plus 1 dx, and add to that the integral from 0 to the mysterious b, right there, we can compute that easy, of square root of 1 minus x dx, which involves beautiful u substitutions, extra negative signs on du, and all of that stuff featured in these integrals because they're awesome, right? Or compute a single integral, which when you solve this for x, you get y squared, you get 1 minus y squared, minus, solve this one for x, that's y minus 1 squared 2 times. From 0 to mysterious c. Which one are you going to opt for? Top or the bottom? Top one? The hell? We have square roots. Look at the second one. Integral of y squared is y cubed. What's the big deal there? This is 15 times easier. Right?
Okay, you can't just substitute for x, let's do something like that. They will then put back to y.
Please don't. So now we are getting into this issue that there is an argument in class. Because some of you are going to push for the top one because you're familiar with x's. Sounds good to set it up that way from calc 1. We're good to go.
what happens when you can't flip, so you have function in terms of x? What happens when you draw a representative rectangle that looks good in the middle, but it's really bad on ends? You see that this representative rectangle goes right the same function on both ends? What happens when you subtract function from itself? Yeah. This problem cannot be solved at all this way, unless you introduce additional cuts and then maybe compute the 6 integrals there. So these dy formulas that are going to be introduced every time we have a new formula in Calc 2 are not there just for decoration. There will be problems that can only be solved that way. So for problem 23, it's your choice whether you want to suffer to use subs and stuff, or you want to do it the easy way, where you just go y cubed and you compute. But you still can't do it the both ways. This one over here can only be done one way, with the dy, because dy in this case is one that will always left side on the black function, right side on the, what do you say, magnesium? What was your color? Magenta, there. Yes?
How would we know in a graph like that which one is the dominant function?
Right minus left.
Okay.
Like top minus bottom, right minus left. Yes? And we got the same answer.
So what's the equal on the right?
They have the same number.
How did I use the walk with do it?
Oh, you did walk it through it. It's right there.
Oh, yeah, I'm doing it.
I'm sorry?
I was just like, how does the y, 1 minus y squared equal like square root of x over 2 plus 1?
It's given. You just solve for x,
okay,
right?
yeah,
You see what I did is I said y squared and then minus 1
Oh, yeah,
and
yeah,
then double,
yeah,
right?
yeah,
Over
yeah,
here,
that's what I-
square and then move it around. Yeah, yeah. Now, can you do that here? Sure. What's y equal to? No. Cosine inverse x, right? Do I integrate that within 6 integrals? Go ahead. So this problem can only be solved. So I'm planning on, let's do this because you love trig so much, and then this one, right? Because you love that so much. So that's a dx problem, and the other one is dy. So we'll do problems 8 and 24, and then you do everything else. Right? You have other 30 problems to enjoy at home. I'll see you next week. So problem number 8. I have to draw this down. Well, I can switch the screen now. Okay. No messing around. So we have secant squared x over 4, and we also have 4 cosine squared x. Those are our two functions. We are looking for the area between the two functions. What I'm going to do is realize the symmetry because both of these functions are even, and just compute 0 to whatever this magic value here is. So 0 to b, and then double it. First, I have to find b. To find limits of integration,
set functions equal to each other. Why? Well, because you will find common x's for common y's. So now, the first order of business is to solve equation secant squared x over 4 is equal to 4 cosine squared x. That's the first order of business. So how do we do this? Yes. Get rid of the force. Okay. How do I get rid of the force? I don't, exactly. So secant squared x is equal to 16 cosine squared x. Now what? Yes. Yes. Nice. So secant is 1 over cosine squared x. And we will multiply both sides by cosine squared x. Kill. So we get that 1 is equal to 16 cosine to the 4x. Now what? Divide by 16. So cosine to the 4x is equal to 1 over 16. Now what? The fourth root. Okay, I'll take the fourth root. And what do I get? And what does that give me? Very good. How you trig equations? All right. Welcome to Calculus 2. You all understand the concepts. That's awesome. You all remember the formula, which is awesome. Can you do any of the problems? That's prerequisites. So we found out that the limit of integration is pi over 3. So I'm setting up my integral. I need to double 0 to pi over 3. And then I go top minus the bottom. Top function is 4 cosine squared x minus the bottom, which is secant squared x divided by 4, all of that dx. So now, how do we integrate 4 cosine squared x?
Substitute for u equals cosine squared x.
But I don't have a sign laying around. Derivative of cosine is sine. How do we integrate this?
You convert it into relation, you get rid of the square sign.
Yeah.
So it would be, so the one thing is that in the last 1 minus cos sine 2x over 2.
So, what did I say last time? It was on the board. The formula for power reducing of sine and cosine. There's no other way of solving it. You know it, you can do the problem. You don't know it, you can just cry. So, power reduction formula cosine squared x is equal to 1 plus cosine 2x over 2. And the one for sine, which just has a minus on top. is going to be crucial to solve problems in this class, chapters 6 and 7. You gotta know this.
And what are those white lines? What?
As I talk. So now, the 2 will cancel the 4. We have integral 0 to pi over 3, 2 times 1 plus cosine 2x minus 1/4. Secant squared is the basic integral, right? Anyone? 10x, thank you. So we have 2 times, and now let's go with integrals. Well, this distributes over both, right? So 2 times 1 is 2, integral of that is 2x. The integral of cosine is positive sine. Sine 2x over 2 cancels the 2, so just plus sine 2x minus 1/4 tangent x plus c. Multiply by 2. Oh, we still have the limits 0 and pi over 3 to worry about. Multiply by 2, we get 4x plus 2 sine 2x minus 1/2 tangent x computed from 0 to pi over 3. There's no plus c because it's definite integral. So we have 4 pi over 3. You guys are developing some serious allergies. Is that trig or just calculus in general? 5 of you sneezed in the last 2 minutes. Or you just like to bless each other. So 4 pi over 3. What's the sign of 2 pi over 3? Very good. And wait, sorry. 2 pi over 3 is root 3 over 2. Minus, that's root 3 over 2. And then we have 0, just kills everything. And there you have it. That's the exact area. Done deal. All right, so now, yeah, a bit more. You're welcome. Problem 24.
What pages?
I never said the page. 417. So this problem is a little bit easy because they give you one intersection point. You know it's pi over 2. We already discussed Oh, maybe I should discuss one more thing. Okay, let me just write this. Sine 2y. Just so we don't run into issues later, I'm going to write integral x1 to x2 of f of x dx. So you see that a and b are values on the x-axis, so I can actually call them x1 and x2. And also y1, y2, f of y dy. When you start mixing up these x's and y's, then you're in Calc 3. Okay? So make sure that it's x across the board and y across the board. If you are doing the dy integral, it has to be y on the limit, another y on the limit, function in terms of y, and look, cosine y. Sine 2y. Previous functions had cosine and sine of x. That was a secant squared x and cosine squared x. So that's very important. Box this, actually put on a cloud. There you go. So you can always access. Can exploit symmetry in this case. I have to set these two equal to each other so I can solve for y. I don't know what this y is on the bottom. The top one is given, it's pi over 2. So sine 2y is equal to cosine y. How's your pre-calc 2? What should I do to solve this equation? Help me.
Sine 2y equal to 2 sine y also.
Yep. The next step is $1 million worth step.
To get rid of the sum. We divide it by
You just got rid of your million. Anyone else? If you divide at any point in equation, you lose solutions. Never divide in equations by variables. Because as soon as you divide both sides by cosine, you just kill the solution. You actually, for trig, you kill 2 or 4 or 8 solutions. Never, ever, ever cancel and divide by variables in equation. You can divide both sides by 2, by pi, but you cannot divide by y or sine y or y squared or x squared. Never divide variables in equations. What is the way that we should do this? Move cosine to the other side, factor it out, and then each factor gets set up to 0. So now when I move cosine to the other side, I can factor that cosine, here negative cosine, and I'm left with 2 sine x plus 1 equal to 0, not xy. Yeah, it's y. It's right there. Look. Y. And I set each one of these to 0. And do you see now where you would lose the solutions? You would not have equation on the left. If you divide both sides by cosine, you kill the equation on the left. You kill this. And you would not have those solutions. Now, when is cosine equal to 0?
no, pi by 2.
Pi over 2. And that's exactly, I mean, we were lucky. Hold on. Whoa. Yeah, that's already given to us. The hell? There we go. So this solution is already given to us, y equals pi over 2. So even if we lost it in this case, we will still survive. But in many cases, It's not. It's not given. So you have to know it. Now this side is sine y is equal to negative 1/2. So what value for y will produce negative 1/2?
No.
Minus pi over 6.
Minus pi over 6, yes. Because we see that we need. You are right. You are correct with 7 pi, not 7 pi over 6, 11 pi over 6. But, so you were not correct. But that would actually happen when these guys make their turns and intersect again somewhere in the future. We need the first one below x-axis, so it's a first negative y you can come up with, and that's negative pi over 6. All right, cool. We have our limits of integration. We can do this. Area is equal integral negative pi over 6 pi over 2. Right minus left. So what do I have? Cosine y minus negative sine 2y dy. So now I have integral negative pi over 6 to pi over 2 cosine y plus sine 2y dy. Integrate. Integral of cosine is sine y. Integral of sine is negative cosine, so negative cosine 2y over 2. Computed from minus pi over 6 to pi over 2. And then you keep computing. So sine of pi over 2 is 1. Minus cosine of pi is negative 1, so plus 1/2. Then the minus, and the minus gives me plus, so plus 1/2. And minus dies, this minus minus another plus, pi over 6, 3 pi over 6 pi over 2, cosine of pi over 2, 0, good. 2. I gotta modify this list one more time. What happens when you set your expectations and goals high? It's like people who do New Year's resolutions. I'm gonna exercise, and like what? 3 days? That's it. Quit smoking, quit drinking.
And like I just set my expectations so low that when I surpass them, I feel so good.
Yeah, that's why my New Year's resolution is play more video games, and more baking, more cake. Yeah, those are the New Year's resolutions. Make you feel good all the time.
So the 4 numbers on the bottom, the 1 plus 1/2, that's the sine y.
Yeah, that's the sine of pi over 2.
Yeah,
and this is the cosine pi over 2, and then negative pi over 6, and then pi over 6 near 0.
Okay.
Right, so those are the 4 calculations. All right, let's do one more problem. I will give you some time to try the problem. All right, so most of the time what you get is word problem, right? Where you don't have graphs, and you don't have graphing calculator on the exam. So there we go. What would be the awful problem that you would like?
9 was terrible.
Nah, you got that. I was thinking along the lines of like 13, 14. 14 looks cool.
Can we zoom in a little bit?
No.
Yeah.
In all of their infinite wisdom in this software,
They don't have a zoom button. Serious. So I have to read and you have to listen and then let's do it. Problem 14 says the region is bounded by y equals 24 root x. Y equals 24 root x. And y equals 3x squared. Exactly. So, this is your test question. You have no graphing calculator, no cell phone apps. Graph it and do it.
So this is the time when you will be working with people sitting next to you. Very good. About 80% of the classroom already figured it out. Checking steps, figuring out. Nice. Those who are not doing that can move. Turn around.
This is the time when I'm like, oh, this makes it so much easier, and then it just makes it so much harder. Let's go. So you got 24 interactions. You can eat one more time. Just because you plug in one, it's gonna yes, yes, that is it. So
It doesn't matter if you know the transparency. Got it. Got to figure out how to write it.
oh, ready for facial for some reason I'm writing on the 16, and I'm like looking at the numbers like these are not adding up. Maybe because they're subtracting, so the opposite of adding up. You get the Are we allowed to check, Professor? Are we
What?
allowed to check our answers with you, or are we about to go over it?
I will go over it. You can talk to others, whatever. Wolfram Alpha, whatever you think.
divided by 1/2 would have given you x to the 3 halves. And then we put a 2/3.
Four. So the 7 equals each other?
Yeah.
Are you sure?
Yeah, hold on.
You got one x is 0, the other one is like 4.
Oh, what?
Divide by 24 you get root x. What's that?
Can I ask a question?
No, I'm playing video games. Yes.
I might have done something wrong. I just don't know what. First, I made them equal. I graphed it.
Yeah.
And then I made them equal to each other, and then I divided by 3.
That's perfect.
And then 8x to the half, and then x squared, and then I moved the x squared to that side, and then I factored out the x half, and then I got.
When you take a half out of here, you stay with 3 halves. It subtracts, not multiplies and divides.
Oh, it adds, right?
Yeah,
Oh,
it says
okay.
3 halves there.
So it's 3 halves.
Yeah.
Because you're adding the.
1/2 plus 3 halves is 2.
Oh, 1/2 plus 3 halves is 2. Okay. Oh, I was doing multiplication, and then that would be, but this would still be right, but then that would change and be. I like messed it all up then, because I was like struggling with that also. So then that would be x.
Perfect.
8. Okay. Thank you.
All right, guys, let's take a look at this problem together. So the issue might be graphing, right? No graphing calculators. So if you are a little bit rusty on that, you can also employ some of the techniques of, remember, concave up, concave down. You know how x squared looks like roughly, and you know how square root looks like. So if you arrange them in this way, it's not going to work, right? If you arrange them in this way, it's going to work. So we are going to draw x squared through origin because there is no plus x, minus x, and those things that would shift function left and right. So there is this 3x squared looking like that. And then x, square root of x must start at 0, because if you plug 0 here, right, its square root of 0 is 0 times 24 is 0, so it must look like that. Now, how fast it's going to, how tall it's going to go, that depends on this 24, but we really don't care. It's just a quick sketch. You know that they intersect on the left at 0, and then there is this mysterious point here, b, right, which we need to compute. We get that when we set two functions equal to each other, and then we compute what that intersection point is. So you can use some of that, I would say, common sense in terms of concavity from, right, and where the graphs are and how they should intersect. Now, you can't use that all the time because, right, x cubed can intersect this way, can intersect, sorry, right on top like this, and so on. But in some cases, you can. So let's go. 24 root x equals to 3x squared, which would be 8 root x equals to x squared. Do not divide x's ever. Bring it over. Keep factoring. So you can say 8 root x minus x squared equals 0. When you have equals 0, you can factor and use 0 product rule. You factor out root x, which is x to the 1/2. You are left with 8 minus x to the 3/2, right? Because 1/2 plus 3/2 is 4/2, which is 2, equal to 0. And then we have square root of x equals to 0, which is 0, which is your a limit. And then you have x 3/2 equals 8, which would eventually be your b limit. So you cube root both sides to get the 3 out. So when you cube root both sides, I have x to the 1/2 is equal to 2. And then square both sides, we get x equals to 4. And that's the b limit. So now what we do is we put that the area between two curves will be integral 0 to 4, those are our a and b, top minus bottom, which is the square root, 24 root x, minus the bottom function, which is 3x squared, in parentheses, because it has to be times dx. Now we integrate each. That will be 24x to the 3/2 divided by 3/2 minus x cubed, because it will be over 3 and cancels the 3 then, computed from 0 to 4. 24 divides by 3, we get 8 times 2 is 16, x to the 3/2 minus x cubed from 0 to 4. We don't have to worry about 0, right, because it will 0 out both, but 4 is there. Square root of 4 is 2. 2 cubed is 8. 8 times 8 is 64 times 2 is 128. Minus, what happened?
Can you do that for 1 Yeah, like how do we jump?
Like this. 16 is 2 times 8, and then you have 4, square root of 4 cubed. Square root of 4 is 2, right? 2 cubed is 8. 8 times 8, 64 times 2. Okay. You're welcome. Free of charge. And 4 cubed, that's 16 times 2 times 2. Very good. And then it's 64. Ta-da! That's it. There are cooler ways to compute this, much cooler ways to compute this, because when you see a 4 here and a cube there, and a 16 there, you get it? Right? Do you? 16 times square root of 4 cubed minus 16 times 4, factor out 16. And you have 8 minus 4, which is 464. Yeah, factoring for computation. And then there is calculator. It's also calculator. All right, 64 is the answer. Yeah, what else are we gonna do? Sure. Let's break with this problem. You're gonna love it. Awesome. Still page 417, so keep tabs. Problem 21. A region is bounded with y equals absolute value x minus 3 and y equals x over 2. Enjoy.
So just there's two lines. Absolute value.
If he was absolute value, then like
Plug into the yeah, but it would just be these two lines.
yeah, but it's absolute value.
Yeah.
So like he's like this, no matter what. Instead of being negative.
Absolute value of X minus.
Oh, I see.
Y value.
Where's the person right now that is? Until it hits well, since it's below the x-axis, where it leads down here, you actually go up. You know? So this negative would just be flipped up. But would it even matter because what's x?
Am I crazy for thinking that's what the graph looks like?
Oh, I know that. I know that. Yeah, one magnet and then one.
Yeah, just to. So it would be like here. And then here.
Absolute value. Yeah, I'm wondering how to get rid of the absolute value.
How do I split the absolute value from over there and behind us?
So one is equal to absolute value.
Guys, you have to break the absolute value of the definition, right? Into two separate functions, and then yeah, because this is technically two linear lines glued together. Yeah.
Just like some of the.
Did you, so, you two different equations then?
Yeah, well, you first graph to see where they intersect, so you gotta see, yeah.
So it's a negative one. So it's so absolute value of minus 3, negative x plus 3, and then x minus 3. And then we need to find where. Oh, okay. That makes a lot more sense. We just need to find where one intersects with the other. Let's see, can I solve this problem without having to take it on an extra sheet of paper?
I think so. I don't know how to. Multiply two thirds and then
I get that.
It's not an intersection.
Yeah, the one on top is oh, I'm still there. So when I'm not up to it's over two on top.
and then minus the, and then.
Yes, very good.
So x equals 2 and x equals 6. Oh, but how does absolute value work with integrals?
Two different functions work together. One with a positive slope, one with a negative slope. So
this is gonna be hard to see my sketch. I don't know, especially now that I drew one. So I would do one integral
the left
q. Right, I guess.
beauty of this.
That's the one you use.
Yes, that's the one.
Not when it's like this.
I can show you more words of 1 plus 1 equals 2 than this.
So x over 2 plus x.
All right, so let's take a look at this together. Definitely the hiccup over here is the absolute value, right? And right? And no, it's absolute value thunders. So I did talk about this absolute value last time, and I told you that whatever is negative just gets bumped up. So you can actually ignore the absolute value and then just bend that negative part up. So as you're looking at this function here, you see y equals x minus 3. So you can graph x equals minus 3 with a slope of, right, that's the negative 3 y-intercept. Slope is positive 1. So it's going to go like this, and it's going to go like that forever. But then you understand that you're not supposed to go below x-axis, so this part has to actually bounce up. Now you also know from pre-calculus that you should shift the function to the right if it's minus 3, right? You know it's a v-shaped function. And then you just erase this piece that you don't need. So that's the absolute value function. And now you have x over 2, so that's at 0, right? Because y-intercept is 0. And then the slope is 1 over 2, so 1 over 2, 1 over 2, 1 over 2, and there it is. Yeah. Now, the beautiful thing about being very precise and using correct paper for mathematics and everything else, I already have my limits of integration, which are 2 to whatever this is, 2 to 6, awesome. And I don't have to solve any equations. Right? Right. But let's say you didn't figure out that there is paper like this and you are not as precise as this, then what do? Well, then you know more about absolute value functions. First of all, the basic definition for absolute value is that absolute value is equal to x for all x is bigger than 0, and it's equal to negative x for all x is less than 0. When x is negative. Now you can put equal sign anywhere. Now, how does that formula work? And why does it work? We know that absolute value makes, that's a consequence. It doesn't make positive numbers. It's a consequence of what it does. It measures the distance from 0 to the number. Now observe how this definition works. If you pick any positive value, well, that's just a value. If you pick any negative value, when you plug it here, negative and negative make it positive. Do we understand how absolute value works? One more time. These are the things. Now you want to check. Pick 7. You plug 7 there, absolute value of 7 is 7. Pick 10, bigger than 0, plug it there, absolute value of 10 is 10. Awesome. Pick negative 5. Well, negative 5 plugged in here, negative 5 is positive 5. Pick negative 10, negative 10 is positive 10. So if you're picking negative numbers, they get plugged in here. If you're picking positive numbers, they get plugged in there. The answer is always positive. So that's how it works. Now what happens if you have shifted function?
How does that look in your definition? Well, looking at the graph, right, your negative numbers should start when x is equal to 3. So this over here, now this 0 becomes a 3 on the break. And then you keep computing. So to make the definition for x minus 3, just think a little bit and play with it, because you have to be able to break it apart because of integration. You can't integrate over the absolute value. You actually have to have two broken pieces and then integrate up to 3 and then after 3, because you don't integrate through this spike over here. It changes the function, right? Let me just strike this red line here and say that on the left, linear function is on top, absolute is on the bottom, right? And on the right is also the same way, but it's a different function on the bottom. You can't integrate absolute. So what do I have? I have over here x minus 3 and then negative x plus 3, right? Because when I apply minus, and this is for values x bigger or equal than 3 and x less than 3. So now I want to try this and make sure that it works. So if I pick 5, absolute value of 5 minus 3 is 2, and 5 minus 3 is 2, so that's cool. If I pick 10, 10 minus 3 is 7, both positive, awesome. Pick a smaller value than 3. Smaller value than 3 is, let's say, 2. So plug in 2. Over here, I will get absolute of 1, and over here 3 minus 2 is 1. Plug in 0. 3 plus 0 is 0. 0 minus 3 is, right, absolute value of negative 3 is still positive 3 that you get from here. So this definitely works. Now, what does this mean? Once you have this, and guys, this is what you actually need to know. You can't integrate if you don't know this. Because these two, this one and this one, are your functions for integration. So this piece of a line here is your negative slope, minus x plus 3, and this line over here is your x minus 3. So now I am setting the integral for all of this, and that integral is integral from 2 to 3 x over 2 minus negative x plus 3, all of that dx, plus the integral 2 to 6, again x minus 2, sorry, x over 2 minus x minus 3, and then dx. Yeah. Yes, it is 3 to 6. That's what I said. Please pay attention. Thank you. All right. And now you work out arithmetic, algebra, calculus, and everything else that you need to. So this was the first part, this analysis of absolute value and which way to break the function. But for that, you have to know the definition for the basic absolute value and how it works. So now we have integral 2/3 of x over 2 plus x minus 3 dx plus integral. I could have combined that into one fraction, 3/2 x. Yeah, let's do it, 3/2 x. Such is life. 3/2 x, there we go. And over here we have negative x over 2 plus 3 dx. And now we integrate. So that's 3x squared over 4 minus 3x from 2 to 3 plus another integral, that's x squared over 4, so negative x squared over 4 plus 3x from 3 to 6.
Guys, you can't cancel the negative 3x and positive 3x because they have different limits to compute. All right? We agreed on that? Cannot cancel. These are two separate problems. If it's easier for you, do one on one page and then flip the page, do the other one, and then put them together. 3 squared, that's 27 over 4. Minus 9. And then minus, that's a square cancels, that's a 3. And then minus plus 6. For the first integral, plus the second integral. You plug in 6, 36 over 4, negative 9. And then plus 18. And then negative dies 9 quarters. And then minus 9. Negative 12, positive 6. So minus 6. And then over here I have plus 9, minus 9, that all dies plus 9 quarters. And then 27 plus 9, 36 divided by 9 minus 3 is 3.
Is it 27 over 9 or 4?
Do you want to go or you want to do more? You don't want to go? Okay. All right. So I will see you all